Good morning and good afternoon, everyone out there on the internet. Thank you so much for joining us today. We really appreciate it. My name is Yuri. I'm a customer engineer here at Google, and I'm joined by my partner in beardedness and laptop sticker collection, Nick.
Hey, Yuri, how's it going?
Good, man.
Yeah, I'm definitely happy to be here. I know that we have an exciting topic to cover today. As you mentioned, my name is Nick Orlev. I'm also a customer engineer, and we are fortunate enough to have one of our amazing rock stars, Karthi, on. Karthi, you want to introduce yourself?
Hey, Nick and Yuri. So yeah, my name's Karthi Thyagarajan. I won't expect you to say my last name. I'm a solutions architect based out of Dallas, and I've got serious sticker envy because all I have is this Google Cloud sticker.
Well, listen, man, you got a long time before you can catch up to us. I tend to be a sticker maximalist, so I'm pretty much just collecting whatever I can get my hands on. Not a whole lot of the discretion being applied. So first, thank you so much for being here with us. You introduce yourself as a solution architect. Can you give us like a 30-second summary of what does a solution architect do at Google?
Yeah, great question. In a lot of ways, we are very similar to a customer engineer. One of the key differences, of course, is that we don't focus on specific customers. We work with various areas of specialty. In my case, it's big data. So I focus on streaming data along with actually streaming and batch, and then quite a bit of app dev as well. So for example, if a customer wants to figure out how they can leverage data flow to do both stream processing as well as batch processing, and they have a lot of experience, let's say, doing Hive on-prem, I would basically work with them to translate some of the existing implementations to doing it in a more cloud-native fashion. So that's an example of what a solutions architect would do.
Yeah, that's awesome. Man, I mean, when it comes to what's valuable to a company, number one is definitely their data and their employees. So being able to extract some useful information and new insights from that data is incredibly powerful. So I'm sure you must be a very busy guy.
You can say that again.
Yeah, and once again, we appreciate you being with us. So as you can imagine, a lot of the questions that we get are around how do customers make use of their data. Some of the questions that I've been hearing more recently are not just about how do people make use of the data basically at the end of their data pipeline or at the end of their processing, or how they can actually answer some questions about what's going on with their data before it even gets to its final destination. We talk a lot about ML. Obviously, we're an AI-first company. Mm-hmm. But people want to know, how do they get sense out of the stuff that's going on in their environment, before they have a chance to train and deploy a machine learning model? So I'm really happy that you're here today, because what I want to hear from you is kind of what you're seeing customers do, especially where different roles within an organization are concerned, to actually utilize their data at all of the different stages of the pipeline or the life cycle. Does that make sense?
Yeah, absolutely. I think that is something that I've heard on multiple occasions as well. So happy to get into it.
All right, let's do that.
Cool.
Great. As based on past meetups, I want to emphasize before I get into the slides that the slide portion will be pretty light, and I think that's a good thing. We'll get into demos after about 4 or 5 slides.
Awesome.
So to start out with, I'll kind of reemphasize the fact that this discussion kind of came out of Nick, myself, and Yuri talking about the data lifecycle solution that we put out. But you can Google data lifecycle on GCP. You'll find it. It should be the first link that shows up. The key here is there are many stages that make up the data lifecycle, starting with collect, ingest, all the way to visualize. But the focus of this discussion, we will kind of talk about the personas, and even within the personas, we'll focus on what a data scientist does. And as Yuri pointed out earlier, we'll look at how we can surface insights from, let's say, the vast amounts of data that any typical enterprise gathers. But I also want to point out that, data doesn't necessarily mean that it should be limited to data scientists or analysts. You'll also have software developers, system architects, et cetera, who have say-so as well as decision-making ability when it comes to how data progresses through the life cycles.
Yeah, absolutely. Makes a lot of sense so far.
Yeah, so Well, as I mentioned, while we won't touch on the software developer side of things, I just want to mention, this is a familiar flow that most folks kind of have been seeing for I would say at least 50 years now, ever since the advent of computers. There's some kind of data collection going on. They'll store it in a relational database of some sort, and then they'll visualize it. So this is the simplest kind of flow that most people are familiar with. To take it a little further, now what we're getting into is the fact that data has become so much more valuable than this previous slide would indicate. Data kind of becomes the engine for entire businesses, and what we're hoping to do today is give you some insight into why that is. And so in this space, you'll see the persona of the data scientist and analyst kind of playing a much more significant role.
Yeah. So looking at this right now, because the flow of the software developer basically ends with the store step, and that's where someone like a data scientist or a data analyst would actually pick it up. So I think the key point here is that depending on who you are, there are different things you need to do with the data. There's different kinds of analysis you might want to do, because even the software developer may need to use the data that's flowing to their system to understand things like system performance, issues that may be taking place, or things that could be potentially negatively impacting user experience. Yeah. And I know that that software developer role or persona is not necessarily the focus of what you'll be covering. We'll be talking more about kind of the other personas in this particular session, but I certainly want folks to think about how do they expose data in their environment to everyone that might benefit from it.
Yep, that's right. And another takeaway I would say is, it is super important for these personas to work together, and the roles are often blurred, as you would agree, because I've often seen data scientists who will wear the software developer hat when it comes time to take all the experimentation they've done with the store and say, okay, now I got to productize this. I got to put this out in production and, let's say, expose a machine learning endpoint that can be called by all these other services. So at that point, you have kind of a blurring of personas as well.
Awesome. Yeah. All right. Let's carry on.
Cool. So as I mentioned, before we get into the demo, let's just look at this very simple flow. Essentially, what we're going to do is we're going to create a toy example. And it starts with this simple driver program that we created that dumps a whole bunch of orders into PubSub. These are orders that have some basic information, as we'll see, like the name of the person that made the order, as well as a widget ID that indicates that they ordered this particular widget. So it'll go through PubSub. It'll be processed by Dataflow. And then from Dataflow, we'll put it into BigQuery. And so that's the store phase. And once it lands in BigQuery, this is where a business, let's say an e-tailer or a retailer, can start to make sense of the kinds of purchasing decisions that are being made by customers. And one of obviously the key insights there is, how are customers deciding what to buy, right? This is a question that often gets asked. So we'll look at some ways of creating models that help us predict some of those purchasing decisions. And we'll use something called Data Lab, which is essentially a hosted Jupyter notebook. And this is usually the realm of data scientists. And from Data Lab, what we'll do is, once we've kind of honed the model, we'll deploy that model to a fully managed serverless machine learning system called Cloud Machine Learning Engine. Does that sound good, guys?
Sounds great. Yeah, definitely looking forward to it. Let's dig into the data.
One thing I want to emphasize here is that we've actually covered a lot of these components of product in other sessions.
Yeah.
Did a session on streaming. So if folks want to learn more about how PubSub works, how you can go about writing data flow transforms, how BigQuery works, we've certainly got a lot of collateral on that. And we've done sessions on this very meetup to cover those. So I don't want to necessarily spend too much time on the infrastructure piece of this, or how do you actually get the data flowing. I think the key thing we want to keep emphasizing, the key thing I'm going to be coming back to as we talk, for the next 20 minutes or so, is how do we use the data at each step, rather than how do we get the data to flow.
Yeah, got it. How do we tie it all together?
No, that's a great point. Yeah. With that in mind, I won't spend any time on Actually, I'll spend very little time on the ingest piece and the processing piece, with the understanding that folks already have kind of seen this presented on this very meetup. So what I'll do is let me just quickly touch on the nature of the data that's flowing through the system. So this is some Python code, and I've kept it simple. So all I'm going to show here is that we have an order ID, an order created date, the name of the customer, something called, something that takes the place of the customer phone number, and then the widget ID, as I mentioned. So these are the fields that you kind of have to keep in mind as the data flows through the system as we inspect it in each of these life cycle stages. And let me also quickly show the data flow processing. And the key takeaway here is how simple it is to write a data flow job. All we're doing here is we're subscribing to a pub sub topic, and essentially, as the messages come in, we are putting them into BigQuery. You have quite a bit of flexibility as far as what you could do with filtering and maybe enriching the data as it's flowing through the system. We're not doing that. So with that said, let's quickly look at what's in BigQuery so that we can then look at what we can do with that data. So as Yuri mentioned, I'm sure you're familiar with the BigQuery UI. This is this Meetup demo DS is the data set that I've created. And within that data set, I have a table called BigQuery demo table. Essentially, that table mirrors the kind of the payload that I showed you earlier. Okay, and I've got quite a few records here. So now let's look at what a data scientist would want to do with this data. And this is where a data scientist is perfectly comfortable dealing with a data warehouse like BigQuery. However, they also want the power of something like Jupyter Notebook. A lot of data scientists work in R and Python, et cetera. In this case, we'll focus on Python with Jupyter Notebook. So Jupyter Notebook has its kind of ancestry in IPython. They renamed it, and now you have all of that kind of power available to you as a hosted service. And the name of that service is Cloud Data Lab. And the way you interact with Data Lab is actually with the CLI. There isn't a UI within the GCP console that you can get to. So essentially what you would have to do is install the Data Lab CLI. And once you get to the CLI, you have the ability to create a Data Lab instance, and then you can connect to it. So as I mentioned, you have create, connect, list, etc. So let's look at Data Lab list to see how many Data Lab instances I have running. As you can see here, I have one instance running, and it's in US Central. And by the way, you can also specify the machine type that you would like. For certain kinds of number crunching, you may want a bigger instance. In this case, I've kind of gone with the standard -4, which is a little bit bigger than what you get by default. So let me pause there real quick, Nick and Yuri. Do you guys have anything that you want me to kind of focus on before I get to the actual notebook itself?
Actually, I have one question. So you're talking about from the overall pipeline perspective, the data is going to be streaming through PubSub and then going into data flow. And then at the end, it's basically piling into the data warehouse being BigQuery. Mm-hmm. Also supports streaming directly into basically into your BigQuery table using the streaming API. Do you mind talking about some of the pros and cons of going your route of streaming through PubSub and then data flow versus directly to BigQuery?
Yeah, that's a great point. So one reason that comes to mind as to why you should go with PubSub is if you want more flexibility, let's say in filtering or transforming the data. If you have requirements that require kind of heavy transformations against the data before it lands in the store like BigQuery, I would definitely recommend that you go with putting data flow in the middle. For simple ingest scenarios, I think it's perfectly okay to kind of leave out data flow, but usually in an enterprise kind of scenario, that's not the case.
Yeah, that makes sense, especially when you're scaling up. So, okay. How about you, Yuri? Any questions that you have before we get kicked off?
No, sir. I want to see how this all is going to work.
There we go. Cool.
Awesome. Okay, so let's get to the notebook itself. So real quick, I already have a notebook kind of running and connected. So when you run Data Lab Connect and give it the name of the actual Data Lab instance, what it does is it creates an SSH tunnel, and then it automatically pops up a browser window like I've done here. And you can see here that the address is localhost 8081. You can change this port to, another port if you so choose. But this makes it really easy to connect to this essentially separate VM with all the goodies installed. So we're talking, NumPy, we're talking TensorFlow, everything that a data scientist would want. And to continue with a kind of a quick tour of what this notebook gives you, if you were to start this up, what you can do is, let me just scroll up here and show you that what you have here with Data Lab is essentially a managed service that anybody who has access to that project can connect to. So every time somebody opens a notebook, what they get is a separate kernel that runs the notebook that they're looking at. And once you're done, essentially, if you're, kind of seeing that the resource usage for that instance is heavy, you can shut down that notebook so that you're freeing up memory, CPU usage, etc.
So, Karthi, let me ask you a question. I imagine that some folks on the line may or may not be familiar. I'm sure they've heard of Python, but Jupyter is a bit of a different paradigm, right? Lots of people are familiar with writing Python code in an IDE. Tell us a little bit about why do people use Jupyter? What does it give them that command line Python doesn't?
No, another great question. So one of the big things is you essentially get this ability to mix Markdown and actual code, so that even if you yourself were the only one working in this kind of notebook, you have kind of self-documenting code. So let me, if I were to open up this guy here, Introduction to Notebooks. And this is, by the way, this is all kind of built into Data Lab. You can open up these examples and play with it. So you can see this looks like a web page, very well documented. You find a cell and you put in your Python code and you hit Control Enter, or you can just click on Run, and it actually runs the code. And all of it is documented. You can save it. You can share these notebooks with other people. So it's the collaboration and the self-documenting aspect of it, I would say, is one of the most powerful things about doing it this way versus running it in an IDE like PyCharm.
Awesome.
Does that help?
Yeah, very much so. All right. So now how do we use data in PubSub or in BigQuery within Jupyter?
Yeah, that's definitely one of the significant kind of capabilities with Data Lab is the integration is built in. So for example, there are these Jupyter Notebook, by the way, gives you the ability to run these magic commands. That's what they're called. And what the Data Lab folks have done is they've kind of enhanced that to add the ability to integrate with GCP services like BigQuery. So this is a magic command here. It's %% BQ query. And then what I can do is submit a query like I would into the BigQuery UI. And then I get the results right here. And that integration is really powerful, because what you can then do on top of this is now you can bring in the power of all the other kind of number crunching, visualization capabilities. So as an example, what I've done here is I've created this variable. It's called DF. In this case, DF to signify that it's a data frame. So the data scientists amongst the audience will recognize data frames. And data frames obviously come with really powerful, data science capabilities, for lack of a better phrase. So you can populate this data frame, and then you can go on, as I've done here, to do some more visualization. So what I've done is I've taken this data frame, and essentially what I'm trying to do here is model the relationship between the person who put in an order and the type of widget it is, just to see if I can actually use it for predictive analytics. So this is, both goes to illustrate the power of combining, all the GCP services, as you mentioned, Yuri, along with what, Data Lab has in terms of capabilities. So in this case, I take the data out of the BigQuery query that I did, and then I'm plotting it. So you can see that there's a linear relationship between the name of the person that put in an order and the widget ID. And obviously this is a contrived example, but this gives you an idea of how you can do some visualization directly against the data in BigQuery.
Very cool. All right, so I think that gives us a great perspective on like the data scientist experience in GCP. Using data from BigQuery as it first arrives, either directly from pubs upstreaming or from a data flow transform. What other persona do you have in mind for taking advantage of data, kind of a different steps of the pipeline over the life cycle?
Yeah, so if we were to kind of go beyond just this ability to experiment, you have the analyst who has to, let's say, actually implement. Actually, before I get to the analyst, let's talk about the system architect who has to maybe implement the kind of the predictive analytics that a data scientist has gleaned from this graph here. So, the data scientist says, "Oh, I have a light bulb moment here. I know that this is how customers are making decisions on what to order. So let us now actually create a machine learning model that will take all this training data, all this gold, basically, and suggest widgets for customers to buy." So to implement this at scale, what a system architect would have to do is essentially go to this training data that's in BigQuery and say, okay, I'm going to do some feature engineering. And to do this at scale, a product that we recently released is called Data Prep. So if you're cool with it, Yuri, shall we move to Data Prep and kind of talk about what that can do for us?
Yeah, absolutely. I'm really interested in seeing, how, now that we understand sort of the life of a data scientist on GCP, I think we want to see, how does an architect benefit from this data as well?
Yeah, the biggest challenge I run into frequently is just the data comes in all jumbled, and there's really no way of simply cleaning it up and preparing it. So love to see what you can do.
Awesome. Cool. So as we discussed, we have this data that's in BigQuery. So let's pull up Data Prep and extract essentially what are called features that'll help us do some predictions. And a picture is worth 1,000 words. So let's actually create something called a flow. What a flow is you can think of it as a transform. It helps you take raw data and kind of shape it into something that you can use for a machine learning model. Because oftentimes you can't just take raw data and apply training to it, because the data is probably not going to be in a shape that you want. So let's do a very uncreative name for this flow here. And what we're going to do is we're going to add a data set that is going to be the source data set for this transformation that we talked about. And for that, I'm going to pick a source. So as you can see, to start off with, you can either pull a GCS object, or you can go to BigQuery as the source, and you can pick a table. In this case, we're going to pick this table, which is where the order data landed. Once we've picked the source, what we can then do is we can edit kind of the way the transformation functions. And we can do it in a visual, kind of UI-based fashion. And this is one of the key capabilities of Data Prep. You're not writing a bunch of code, which there's nothing wrong with writing code, but a lot of times it's hard for people to picture what the data looks like. And that's one of the really powerful aspects of Data Prep. So we have the source data. So we create something called a recipe. And a recipe is something that essentially applies to the data. And let's edit this recipe to kind of tell it what to do with the raw data here. As you can tell, it's loading the demo table that I created. And I'm sure you'll recognize all these columns. You know, it's the same columns that I showed you in that Python class, order ID, order created date, etc. And right off the bat, what you'll notice is data prep does a good job of adding visual indicators to the data. So for example, you know, it'll tell me this name, Jennifer Smith, occurs 0.04% in the whole data set. So these are really cool. But what's even more powerful is it'll tell me, hey, there are different kind of shapes for customer phone number. And also that there are 1925 rows that don't have customer phones. So you can see there's a lot of power here in kind of giving you the ability to filter, leave out things that may not be helpful.
I think that's a really important point there is that you can quickly understand, you know, what does the data look like? Do I have outliers? Are there gaps? Mm-hmm. So, you know, if you're, let's say that the thing you were trying to figure out is, you know, the location of your customers. Phone number might be a really important piece of information there because the area code gives you, you know, very precise location information, even if you don't have GPS data or anything like that. And if that's a key part of what you're doing, then having some significant portion of your data not have a phone number makes it somewhat less useful.
That's right.
And just out of curiosity, it seems like this does a lot of the transformational piece that data flow also drives. So what's the relationship between data prep and data flow?
Great point. Data prep is actually built on top of data flow. And the reason that's significant is that once you kind of, as we'll do here, once you kind of create this transform, it is actually run within data flow, which means we can deal with hundreds of terabytes or even petabytes of data because of the scale out capabilities that data flow brings to the table.
Awesome. That's interesting.
So
yeah, so let's actually, sorry, go ahead.
And then I'm sorry to interrupt you. You know, in the interest of keeping this to a manageable length, because I think we could easily be here for an hour or 2 hours talking about everything. I think this, you know, this visibility with data prep gives folks really excellent understanding of how they can go about doing some of that data wrangling and data cleanup, and then, like you said, right, creating those transforms that would then, you know, make this data more useful or actually clean it up automatically. So let me ask you to shift gears a little bit. Let's talk about that last persona that we wanted to cover.
Yeah. So essentially, this is the persona that kind of brings together, you know, the machine learning, the data scientist with, you know, with the machine learning models, as well as the analyst, and then also the system architect. In this case, this is the person that's implementing the entire system, and then bringing it online so it can do online predictions and things of that nature. So I'll segue to that persona by talking about how data prep can be leveraged to generate the raw data to do the machine learning. So in this case, I've picked out all the raw data that doesn't have missing order IDs for whatever reason. And then I run this data flow job, and as Nick pointed out, this data prep job, as Nick pointed out, just to show you, when you run a data prep job, it actually shows up in data flow, as you can see here. And this just confirms the fact that underneath the covers, data prep is actually using data flow. Okay, so with that said, let's now jump back to our Jupyter notebook and kind of look at our you know, kind of system architect persona, how they would take a machine learning model that the data scientist has put together, and how they will generate a prediction engine for predictive analytics.
All right, sounds great.
Awesome. Cool. So, you know, this is going to be very light in terms of actual machine learning modeling. I mean, this is a very unsophisticated model just for demonstration purposes, so keep that in mind. Anyway, so the data scientist has determined that there's a very simple linear relationship between the name of the person that's making the order and the widget that ends up getting ordered. So what we're going to do is we will take the cleansed data that data prep puts into a GCS bucket. It's in the CSV file. Let me select it here. And with that, what we will do is we will create a training data set. as well as a test data set. And this is actually how, TensorFlow typically works is you have to have a training data set, and then you train your model with a certain number of iterations, and then you test that model with the test data set to make sure that things aren't out of whack. Cool. So the way you do that without going into too many of the details is you basically, as I mentioned, you basically create the training data set and the test data set, and then you leverage something called an estimator. This is built into TensorFlow, and you have a variety of estimators that you can pick from. In this case, we'll use a simple, linear regression model here to train, and we'll set up inputs that come from the training data set that we talked about. And essentially after that, we say, hey, let's run this training for 300 steps and one evaluation that goes against the test data set that I mentioned. With all of that kind of put into this task Python file, what we can then do is try out the model locally. And all I have to do is run the model. This is, by the way, not running on ML Engine, even though it is referencing ML Engine. What this is doing is, taking the training data and running it in my data lab instance. So that's important to remember. Once that's, satisfactory, we're happy with the model performance, things like that, we can actually run it in the cloud. And the way the flow would go is, so the system architect, let's say, would try this out in the cloud, and they would leverage the power of the GCP cloud. They have the ability to pick a whole bunch of scale tiers. As some of you may know, training is often the most time-consuming aspect of doing predictive analytics, because it requires some serious horsepower. And this is where being able to tell Google Cloud Machine Learning Engine, hey, I want to use 10 machines, or I want to use 3 GPUs. You can specify all of that here when you're doing the training in the cloud. You may bring in terabytes of data to do that training. So then, the training is done. You also then have the ability to kind of look at the characteristics of, I apologize, I have to rerun this again, but basically, if you guys are familiar with TensorBoard, you have the ability to kind of look at where the model lands and all the characteristics of the training, and you can inspect it with TensorBoard. So that'll tell you, hey, this is the loss function, this is how long it took to run, things of that nature. Once you've run the model and you're happy with it, you can deploy it. And what does deployment mean? So deployment has to do with actually having Cloud Machine Learning Engine. Once again, this is fully serverless. We're not talking about individual computers or your own managed cluster. We're talking about a managed service hosting the model for you, and then you can have it do predictions. And the way that works is you essentially tell it, hey, this is where my model is after training is complete. In this case, it landed in this, when I say it, machine learning engine, after the training is complete, landed the model in this GCS bucket that you specified. And basically, you can take that model and then use it to do predictions. And what we're going to do here is basically pass it inputs just to see, hey, what kind of predictions am I getting? So this is something we can actually do because I've deployed the model with Machine Learning Engine, and you can do it. You can do it actually directly from Data Lab. That's one of the cool things about using Data Lab is you don't have to exit this environment that data scientists are probably comfortable in, or also system architects, and leverage the model that you've deployed to production to do some predictions. Let me pause there real quick while this is running and see if there are any additional questions that I can address.
Yeah, anything on the live stream?
We don't have any questions in the live stream, but I think this may be a great place to wrap it up. Thank you so much for showing us how data can flow through a pipeline in GCP. Thanks for showing us how to make sense of it, kind of as it arrives in BigQuery and some of that first level of analytics you can do just with things like SQL queries, how to do that next level of analysis as a data scientist using, a host of Jupyter service with Cloud Data Lab, how to make sure the data is good and clean and useful with data prep, and then how to take it to the next level with either local ML or a cloud ML engine. I thought this was fantastic, really useful information. Thank you, Karthi. Really appreciate your time. Like you said at the start, you're a busy man, and we really appreciate you taking the time out to talk to us.
Yep, absolutely.
Really enjoyed it. Thank you for your time.
All right, folks. Thank you so much. As always, like, rate, and subscribe. Right, that's what you say when you're on YouTube. And Nick and I will be back next week with another GCP customer story. So please tune in then. It should be on the schedule already, or we'll get on the schedule as soon as possible. Thanks, everyone. Have a great day, and we'll talk to you soon.
Yep. Till next time. Thanks, everyone.